Hey guys, I have your notes pulled up for section 4.3, and we're going to do trig derivatives today, and I've kind of got good news and bad news. The good news is the notes are going to be short. The bad news is I'm giving you a lot of stuff to memorize, and it's yucky, and I have nothing for you. Like, I have nothing to help you memorize these. Sorry. You're not going to use them that often, so like when you're doing homework, feel free to have your notes right there with you. As far as are they going to be on a test or quiz, what I typically do is I put them on the quiz, and then I don't put them on the unit test. Well, I've eliminated all quizzes from first semester because of COVID, so I don't know. If it's on the test, though, I'll be sure and let you know that they're going to be on the test, okay? All right, so trig inverse derivatives. Before we get started, more good news. You can cross out this last example on the back of your notes. We're not going to do that together. I do want to use this space. This is really important notation that I need you to know. So when you see this, you know that you can also write it like this. Worksheets, textbooks, anytime they want you to square sine of x, they'll write it like this, okay? So you all know that these two are interchangeable. Most of you do better when it's written like this, but you're going to mostly encounter it like this. All right, what if you see this? To the negative 1 power. It means 1 over sine x. It means take that whole quantity and move it down. What you can't do when this is a negative 1 is you cannot use the top philosophy on it and say that sine of x to the negative 1 is equal to, okay? That is not true. No, not true. Because this has its own meaning, and it's sine inverse. Now, just a quick reminder about inverses. So on normal trig, this is how I taught my classes trig. When you're doing regular sine of something, this spot right here is reserved for your angle. That has to be your angle. And when you do your sine function on that angle, your result is usually a fraction. I know sometimes it's 0, sometimes it's 1, sometimes it's negative 1, but usually it's like something over 2, or it's usually a fraction. So I'm going to call it a fraction. Sine inverse. This is inverse. This is not sine to the negative 1 power. This is not 1 over anything. You've got to look at it in the context of the problem. This is sine inverse. This means take your x's and your y's and swap them. Take your angle and your fraction and swap them. So when you're doing an inverse problem, this spot right here is reserved for your fraction. And your answer to the inverse is what the angle should be. So you'll see a problem like sine inverse of 1/2. And it's your job to come up with pi over 6. So that's what inverses are. We've swapped the angle and the fraction location. All right. So I'm going to show you the 6 trig inverse derivatives. Now, keep in mind that when I show you these, I am showing you these, and none of them contain a messy. So you remember when I taught you trig derivatives, the derivative of sine of x is cosine of x. When I first introduced those derivatives to you, we hadn't talked about messy yet. So I'm going to show you these without anything messy, but then they're going to get messy. But that's okay. You're going to know what to do with them when you encounter the messy. All I've got to show you is the actual derivatives that you have to memorize. So, here we go. Sine inverse. The derivative is 1 over a radical 1 minus whatever that is squared. That's the derivative. So if you're doing the derivative of sine inverse of x, then your derivative is going to be 1 over radical 1 minus x squared. If this is messy, this is going to be a quantity messy squared times the derivative of the messy. Next one. For cosine inverse, the derivative is exactly that, but opposite. So there you go. Caught a break there. Okay. Tangent, I'll tell you what, tangent is actually the most common and it's the easiest. Good news for you. So the derivative of tangent inverse is going to be 1 over 1 plus x squared. No radicals in there. Again, if this is messy, this is going to be messy quantity to the second power times the derivative of the messy. And you know what? Since you saw a pattern with sine and cosine, there's a pattern with tangent and cotangent. So let me skip down here to cotangent. The derivative of cotangent inverse is the negative version. So if you've got one of those memorized, you can probably always figure out the other one. And then cosecant and secant. Secant is going to be the positive version, so it's going to be y prime equals 1 over, super ugly, x. X radical x squared minus 1. And then this one is the worst. It's the negative version. Negative 1 over like that. So if you can memorize sine, cosine is just the opposite. If you can memorize tangent, cotangent is the opposite. And if you can memorize secant, cosecant is just the opposite. All right, let's try a couple. It's telling us to do the derivative, and we need to recognize that this is messy. Here we go. dy dx equals, well, cosine inverse derivative looks like this. And then whatever was in the problem is what gets squared. So it's the messy squared. And then we have to come out here and say times the derivative of the messy. Clean it up a bit. Don't forget that the 3 has to be squared as well. Next one. Your angle isn't just x, it's messy, so here we go. positive version. Messy. Squared times the derivative of the messy. There you go. Last one. Particle moves. All right, so we got a position function, again, named x. Weird, but okay. What is the velocity? So we've got to do a derivative and plug in 16. So v of t equals, you know what? I think I'm going to do a quick rewrite on x first. X of t is equal to tangent inverse I'll do that. It's t to the 1/2 power. This is messy. Now I'll do derivative. Derivative. 1 over 1 plus messy squared. Times the derivative of the messy. All right, what can we do here? Nothing is going to be in the numerator besides a 1. Let's see, there's going to be a 2 down there because of this. There's going to be a radical t down there. And there's going to be this quantity right here, which is the quantity 1 plus t. 1 plus t. Because t to the 1/2 times 2 becomes t to the 1st. All right. Let's take our velocity and plug in 16. Two times 4 times 4 is 8. 8 times 17. I already did the math for you. It is 136. Velocity at 16, seconds.